What they asked me to do is kind of cover some basics of fall protection, cover some of the history of fall protection, but also I wanted to bring in a new PowerPoint we just did called Innovative Solutions, where we talk about specific problems. Some of them don't apply to you, so I'll gloss over those because I got a short topic course. But what we'll talk about is some of the basic history. It started in 1930 when we used to have real reality shows as opposed to the ones we have now where they actually taught you something. There was a reality show on public TV on the building of the Golden Gate Bridge. It's about 10 years ago. Some of you may have seen that. And when they talked about that show, they referenced that that was the first project in the United States that required fall protection. And it wasn't a government agency that forced the fall protection. It was the architect. And that guy said they just finished building the Bay Area Bridge, had a lot of fatalities on that job. He said, not on my watch, and he made fall protection mandatory. So it didn't take the government to save people's lives. It took one man. And that project worked pretty well. They had a tragedy at the end where some scaffolding collapsed into a net, cut a hole in the net. Nets aren't designed to catch metal. It tore a hole in the net, and 9 guys fell through and drowned. But it saved another 11 guys, so it proved fall protection would work. That's when Clarence Rose got started. He was making the body belts for that project. I had the pleasure of working for Clarence Rose in 1976 when I went to work for them, and he truly was a pioneer. Unfortunately, most of the stuff we still use today is based on technology that Clarence Rose invented back in the 50s. It was great in the 50s, but I think it's archaic now, and yet we still rely on the same thing. A 6-foot lanyard and a 42-inch shock absorber, ensuring that the guy's going to hit the ground about 90% of the time. So we need.
Cargill requested testing of a horizontal lifeline system that could be used for fall protection when a fixed system is not available. We conducted the test using a Capital Safety SafeLine system and several styles of lanyards. The dummy used was a 160-pound unit borrowed from a local utility. The objective was to have a system that could be installed by one person and provide fall protection when working on top of the rail car. Installation begins from one side of the rail car, working from the fixed ladder. The standard SafeLine system is equipped with a 6-foot tie-off adapter, but it was determined that a shorter length would be easier to use. Once the tie-off adapter is attached to the top rung of the ladder, the horizontal lifeline is attached to the D-ring. It might be easier to carry the system to the top of the car in the bag. The unit is then tossed over the side of the rail car to the ground. The installer then carries the horizontal lifeline to the other side of the car, and the attachment process is repeated. On this side, we switch to the strap that is only 3 feet in length to facilitate adjustment of the horizontal lifeline. This is the length I recommend for this application. Once installed and adjusted, the system is ready for use. In this simulation, my lanyard is equipped with the old non-ANSI approved gates. A 3,600 pound gate should be used in this application. To conduct the drop test, we utilized the fixed system as an anchor point for our winch. This allowed us to raise the dummy to simulate work from the platform. We use a 6-foot Force 2 lanyard. You may notice a kick-up of dust as the feet of the dummy hit the ground. But we did retension for the second drop. In the second drop, we used a Easy Stop 2 lanyard that was only 4 feet long. But we did retension the system. In the final drop, we utilized a Talon self-retracting lifeline. It appears there was some deflection in the catwalk during the drop. Encircled is the amount of activation of the shock absorber on the horizontal.
Any questions? So it's feasible, takes time. This is just the first run. Nobody's wanted to spend any money on this because it's just like the roofers. We had no roof anchors. Once people know nobody's going to enforce any rules, there's no incentive for manufacturers to spend any money on R&D. But just like with the roofing anchors, I'm sure we're going to come out with a lot of new portable systems for rail car, rolling stock, because it is coming. The changes are going to happen. Any other questions? I actually answered none, so anybody have any questions? Okay, well, thank you very much. Appreciate the time.